Good evening, students. So, for in our last class, we have seen up to takeoff and landing. So, next thing in the flight performance, what we need to see is range and endurance. First of all, what is range? We know the aircraft. Normally, the efficiency of an aircraft is calculated based upon the finding the range and also the endurance. Okay, and if we can for a same amount of fuel, if we can increase the range, and also we can, if we can increase the endurance of an aircraft, we know the aircraft is more efficient than other aircrafts, if by using some devices or some techniques or whatever maybe. So for an aircraft, in order to increase the performance of aircraft, or to optimize the performance of an aircraft, we need, what we need is, we need to customize certain parameter. That parameter is, one is range and another one is the endurance. Okay, so the general definition for that is, range is the horizontal distance covered by an aircraft from a starting point, or from engine start. Okay, with a given amount of fuel. For that means, for a full amount of fuel, how much distance an aircraft is covering, that is called range. So, and the unit for range is, it is simply the distance. So we can measure the range in kilometers. Okay, normally range is classified into two types. One is safe range and another one is gross still air range. Safe range is the maximum distance between two destinations over which an airplane can carry out a safe, reliable or regular surface with a given amount of fuel. That is a normal thing. That means, normally, for a particular aircraft, for a full load of fuel, it will reserve some amount of fuel. Okay, and normal surface, that means, if an aircraft is taking off from let's say Bangalore, and it is its destination is Chennai, means during its travel, normally it will take off from Bangalore, and it will reach and it will land in Chennai. If normally it is happening, means then no problem, that is called safe range. Sometimes in some airports and all, if there is a lot of traffic in while for landing, means so many aircrafts are landing, and there is a traffic, means they will ask us to loiter for some minutes. So even for loiter, it will have some amount of fuel. But suppose the loiter time is increased, means then it won't come under safe range. So safe range is the thing. Normally an aircraft, it is a distance covered by an aircraft during a normal travel. Okay, that is called safe range. Gross, the second one is the gross still air range. That means, now it is a horizontal distance covered by an aircraft during the flight, and with the fuel exhausted. If a fuel is exhausted, means then, that means, it has one full amount of fuel, and the aircraft will fly up to the fuel is exhausted. That much is the gross air still air range. Okay, so normally, for range, the term for denoting the range is R. So R is equal to WF into kilometer per Newton of fuel. So WF is the weight of the fuel into kilometer per Newton of fuel per amount. That means the amount of fuel, how much distance is here. That will be come under the weight of the fuel also. Okay, we can calculate that in terms of weight of the fuel also. So for estimating the range, what are all things we need to be considered this? We should consider thrust required, TSFE, that means thrust specific fuel consumption, then flight velocity and lift coefficient, and also specific fuel consumption of an engine, or thrust specific fuel consumption of an engine. So the thrust specific fuel consumption, it will be in the unit is Newton per kilowatt hour. Newton per kilowatt hour. Okay. So for driving things, we are not involved in doing all those things, but because there is no time, so we will move it a little bit earlier itself. But I will give some time for noting the formulas and all, and we will solve some problems. In while solving the problems, we can understand how how we can solve the sums and all. Okay, and the concepts also it will be covered under the while solving. So here the weight of the fuel is considered as W. That is the total weight of the fuel at a time t, and weight of the airplane, that will be W, and the weight of the fuel from the initial, that means from the beginning of flight, is WFI, or we can say WF1 also. And W1 is the weight of the airplane at the start of the flight. That means when the aircraft is starting, the weight of the fuel will be WFI, and the weight of the airplane will be W1. Okay. Then so we can't find when we are deriving some equations, and or we are about to find some equations. What we won't take a whole area. We will take a whole area, but in that whole area we will take a small part, and we will find the value for the small part, and after integrating we will get the entire thing. Okay. So first of all, I am just taking the small thing. So the range of the small area will be, or some, the distance will be dr, and the weight fuel consumption for that will be, we know r equal to what, wf into kilometer per newton of fuel, per newton of fuel. Okay, these things are no problem here. For from this book, I what which I referred, it will be, it is like this, that's why. Okay, so for small thing, dr equal to dwf into kilometer per newton of fuel. Okay, that's it here. So for an hour we can cancel like this, kilometer per hour in the newton of fuel per hour. Okay, per hour. So kilometer per hour will be, we can put it as 3.6 into v. Okay, that will be the in meter per second. So 1 kilometer per hour equal to 3.6 meter per second. So for the like that, it will be like this. So and fuel per hour in newtons is equal to, the fuel per hour in newtons is equal to, 1 second, BSFC into BHP for engine powered airplane, and for jet engine it will be TSFC into T. Okay, TSFC into T. So while substituting, we will be getting the equations like dr equal to, we know dr equal to dwf into kilometer per hour divided by newton of fuel per hour. Okay, first of all, it is will be the general formula will be into kilometer per newton of fuel. Well, considering for our kilometer per hour, how much kilometers concerned, therefore like that means, and how much fuel is consumed for per hour means, we can put it as kilometer per hour divided by newton of fuel per hour. Okay, so for that we are just writing like dr equal to dwf into 3.6 v divided by bsfc into bhp. This is for propeller engine combination. Okay, then for jet engine combination, it will be TSFC into T. Same formula, but in place of BSFC, here the thing will be TSFC into T. Okay, this is for jet powered. And so just note this two formulas. One is this one and this one. Okay, and one more thing. Here we will derive the equation of dr in terms of r. Okay, for that purpose only I will just go through that, and because it a little bit faster, because we don't need the things like this. We want the formula in the form of this only, this r and this one for jet powered. And so I will just go through that. So for deriving this, here we have a thing called thrust, and we have a thing called velocity. Okay, and we have a thing called TSFC, that is a thrust specific fuel consumption. So if you know the values for these terms, we can easily derive the equation and find the value for the range. Okay, this is a general terms. So while deriving, we will be getting some other equations. Okay, so for that we know T, for a steady level flight, T is equal to D. For d, we can write like this, d into L by L. For L by L, we can put like C, and for L equal to W, that we know for steady level flight, L equal to W. So here it will get W into CD by CL. And but we know L equal to W equal to half rho V square S into CL. Okay. So from that we can find the value for V, that is V equal to 2W divided by rho into S into CL the whole power 1 by 2. And for this rho we can write like this, that is the density ratio, that is sigma equal to rho by rho naught. So from that sigma equal to rho equal to, we can write like sigma into rho naught. Okay. So 2W divided by sigma into rho naught into S into CL the whole power 1 by 2. And this rho naught is the density because it will fly at certain different heights. So the density ratio will be considered for an airplane for flying at different heights, and it will reach when it reaches the ground. We need to consider the terms, because first of all we will be considering it is in a sea level condition, but some other altitude, then altitude ratio will come. So for finding that things, we need this formula. Okay. So we can write like V equal to 1.278 into W divided by, after substituting all those values, it will be reduced in the form like this. Okay. Substituting this value, that is rho naught equal to 1.225 kilogram per meter cube. We will get the equations like V equal to 1.278 into W by rho sigma S L whole power 1 by 2. Okay. Now we can substitute the value in this equation. Okay. And by substituting it, we get the equations like for and for BHP also there is a formula like this is from this thing also we have learned in power, for finding the power. BHP equal to 1 by eta P into T into V divided by 1000. So here also we can substitute the value for T, and we can substitute the value for V also. So that after substituting this value BHP, we can substitute here, so that we will get the value like BHP also T into V divided by, it will come like this. Okay. T into V divided by eta P into 1000. So while substituting it, we will be getting the values like for BHP 1 by 782.6 W power 3 by 2 divided by eta P sigma S whole power 1 by 2 CD by CL whole power 3 by 2. So we know this, the weight of the airplane, that will change when an aircraft flies from, or when an aircraft covers certain distance during its flight. Okay, that means we know from this, consider this is the point of starting and this is the point of ending. Okay, when the at this starting point, consider the weight of the airplane at 120 kilonewton. Okay, just we can, for our simplification only, I'm just giving this example. The weight of the airplane is 120 kilonewton, and when an aircraft after the flight missions, we have a ground run, then climb, sorry, take off, then climb, then cruise, and loitering, then descent and land. Okay, so these are the phases. We know when an aircraft climbs from here to here, it will take some time. Okay, and also we know when covering this distance, automatically there will be some change in weight. Okay, that change in weight may be because when at the starting point it will be at full load of fuel. Okay, full load of fuel, but when it reaches here, the load of fuel will be somewhat reduced, and it will be like up to this. When it reaches to the landing, it this fuel will be like this, so the weight will be much reduced. Okay, so that's why dwf is equal to minus dw. That means depend upon the fuel consumption, automatically there will be some reduction in weight of the airplane. Okay, so substituting all those terms, we will be getting the equations like r equal to integral of w1 to w2 minus 3600 into eta p into dw divided by bsfc into w into cd by cl. This is for engine power, propeller combination. Okay, if there is a propeller, you should use this equation for finding the, sorry, this one for finding the range. Suppose for a jet powered airplane means we can substitute the equations like minus 4.6 divided by tsfc sigma s w whole power 1 by 2 cd by cl whole power 1 by 2. Okay, power 1 by 2. So this equation we have there is a term like integral of dw. Okay, integral of w1 to w2 of dw is there, so we can reduce the equation. We can integrate this and we can find the solution for the equation. Okay, so there is a general equation for range. When the required formula for range of an airplanes for the both engine powered and jet powered airplanes are, for that we have some assumptions. Just note this assumption also, because sometimes they may ask like what are the assumptions, like that. Okay, so for deriving the required formula, we should consider like the bsfc or tsfc. Okay, that is a thrust specific fuel consumption will be constant, and also the efficiency of the propeller is also constant, altitude is constant, and cl is constant. Okay, and this thing is independent of Mach number, so no need of considering that. So the equation becomes r is equal to minus 3600 divided by bsfc. We are going to do what are things we need to do is we need to integrate this thing only. Okay, this dw divided by here also for jet powered and for engine powered also, what we are going to do is we need to integrate the weight of the airplane, that is a dw by w. Okay, so after integrating we will be getting like 8289.3 eta p divided by bsfc into cd by cl ln w1 by w2. This is for engine propeller combination, and for jet powered engine, r is equal to 9.2 divided by tsfc cd by cl power 1 by 2 into w1 divided by sigma s whole power 1 by 2 into 1 minus w2 divided by w1 whole power 1 by 2. This is for jet powered airplanes. Okay, jet powered airplanes. So just write these two formulas for the for solving this. In some books some other formulas are there. I will show you the formulas also. We will give the formulas also. One second, I will Normally this formula will be like this. I will write you the formula. Normally the formula is R equal to eta divided by C. This is from one book. Okay, CL by CD ln W0 divided by W1. Okay, so this is also one type of formula. This is for range, and for endurance I will we can derive that later. And for jet powered and all, like this only. Normally you can use this formula for this is for propeller driven. Okay, and for jet powered airplane I will write the formula for the jet powered airplane. This is for EPC. Okay, this one, this formula. Here some things they have considered, that is here the eta is also eta p here, and for CL by CD they have put here CD by CL, and C is that BSFC. For that thing only they are putting the specific fuel consumption. This is specific fuel consumption only, it will be like this. Okay, and ln W0 by W1. W0 is the W1 here, and W1 is the W2 here. Okay, this one. Okay, so same thing only for general thing is for that C we are putting like this. Sometimes they may give the value like specific fuel consumption, so that you can use this formula. Okay, other things only you can use that formula. Okay, and one more formula for our jet powered airplane. This is for propeller airplane. Okay, for jet powered, for jet airplanes, R is equal to 2 square root of 2 divided by rho s 1 by CT. This CT is also thrust specific fuel consumption. Okay, CL power 1 by 2 divided by CD into W0 of 1 by 2 minus W1 of 1 by 2. Okay, this is these things and all depend upon the problems only. Suppose they have given the values like sigma s and all given means sigma s, then TSFC is given means you can use this formula also, or else you can use this formula. Both are correct only. For briquette range and range for jet powered and propeller powered engines, we can use both formulas. Okay, no need to worry about this. Sir, this thing is easy. Which one is easy, you can just add in for yourself, so that you can use that. Okay, so if the thrust specific fuel consumption is minimum means the range will be maximum, and also the CL power 1 by 2 divided by CD is maximum means range is maximum, and the surface area is more means range will be minimum. Okay, like this things only, but these things also I am just saying from the formula only. Okay, here also if BSFC is more, automatically range will decrease. If BSFC is less, the automatically range will increase. Okay, that means the consumption fuel consumption is more means automatically range will decrease only. So for an aircraft the fuel consumption should be less. So we should design an aircraft in such a way so that we can increase the performances. The same manner CD by CL, that also if we can increase the CL, automatically range will also increase. That means if other things will if CL is contributed more means automatically if CL is directly proportional to range, so automatically range will increase. Okay, so next is the endurance. Endurance means nothing but the time aircraft flies in air, remains in air for a full amount of fuel. Okay, so it is the time for which the airplane can remain in air for a given amount of fuel. and this thing is, it is measured in hours. So here also, during its flying time in endurance, the weight of the fuel will change. Okay, so it is also directly proportional to the weight of the fuel, so that is equal to wf into, that is the weight of the fuel, into hours by per newton of fuel. Simply we can say hours per newton of fuel. There are kilometer per newton of fuel, here hours per newton of fuel. Okay, so for finding the whole thing, we will be same manner, we will be taking small endurance, that is a de, that is equal to dwf into hours by newton of fuel. Okay, so same manner here also, for a kilometer per hour, we can put like 3.6 into v, and the fuel in per hour in newtons is equal to bsfc into bhp. Same thing only for engine powered, and for thrust jet powered airplanes, it is csfc into t. Okay, so here also d equal to dwf divided by bsfc into bhp, and also for engine powered, propeller powered, and for jet powered, d equal to dwf divided by tsfc into t. Okay, and here we can say t is equal to d equal to w. These things and already we have seen, so no need to derive that once again. So the equation becomes, so we just will tell t equal to d, that is from steady level flight, that equal to, we can write like w into cd by cl. Okay, and we know l equal to w equal to half rho v square s into cl, and v equal to 2w divided by rho s into cl whole power 1 by 2. Okay, so we can put like, that is equal to 2w divided by, for density rho, we can write like sigma into rho infinity. Okay, sorry, rho naught into s into cl whole power 1 by 2. So by substituting, we will be getting the value for vs, v equal to 1.278 into w divided by sigma scl whole power 1 by 2. So after some simplification, we will be getting like of this bhp, we can substitute the bhp value, that is d equal to minus 782 into eta p into sigma s whole power 1 by 2 dw divided by bsfc into w per power 3 by 2 cd by cl power 3 by 2. This is for engine powered combinations. Okay, and for engine propeller combination, and for jet powered combination, we can write like d equal to, there is for, that is for t only. Okay, so t we can just like write w into cl cd by cl. Okay, so minus dw divided by tsfc into w cd by cl. Okay, so we know after this we can integrate this for w1 to w2, but in the Anderson book they will be giving like w0 to w1. W1 is the total distance traveled, or total the weight of the aircraft after landing and all. Okay, so equal to w1 to w2 of d. So the equation becomes integral of w1 to w2 minus 782.8 into eta p sigma s whole power 1 by 2 dw divided by bsfc into w power 3 by 2 cd by cl power 3 by 2. So, and for endurance, we will be having like equations like minus dw divided by tsfc into w into cd by cl. So after the integrating and taking the constant terms outside, we will be having the equations like e equal to 1565.2 eta p divided by bsfc into cd power by cl whole power 3 by 2 into sigma s divided by w1 whole power 1 by 2 into w2 of 1 by 2 minus w1 of 1 by 2. Students, write this equation. This is much needed equation. Okay, in the same way, for jet powered, e equal to 2.303 divided by tsfc into cd by cl ln w1 by w2. This is for jet engine. Okay, write these two equations. Okay, next we can solve one problem. This we can easily understood why how to solve problems regarding this. Okay, so I will tell you what things are given. So here an airplane having a engine propeller combination. So they have given the aircraft with the engine propeller combination weighs 88,290 Newton. So the weight it is 88,290 Newton. Has a wing area. It's so S is given, W is given. Okay. Its drag polar is given by, so the drag polar is given. So then what we need to find is we need to find the CL. Suppose in any question drag polar is given means first of all we need to find the value of that CL. Okay. And we can easily identify the, so they have given the value for CDO and also K. Okay, because of this equation it denotes CDO plus KCL square, KCL square, that only it is given. So CD equal to 0.022 plus 0.059 CL square. Okay, obtain the maximum range. So what we need to do is we need to obtain the maximum range and endurance at sea level, in a steady level flight at a, so we should find the range and endurance at sea level condition in a steady level flight at a constant angle of attack. So the angle of attack is constant. For the following data, additional data, what and all is given is weight of the fuel and oil, that is equal to 15,450 Newton. BSFC, they have given the value for BSFC, that is equal to 2.67 Newton per kilowatt hour. Then the propulsion efficiency is given. Okay, that is eta P is given. So the propulsion efficiency is eta P, that is given. Weight of the fuel WF is given. CDO KCL square given. Surface area, this is S is given. Weight is given. Okay, so we need to find the what and all things need to find. We found means maximum range R. Okay, maximum range R and E. Okay. 1 second. So here initially the weight of the engine is, airplane with having a engine propeller combination with the weight of the engine is W1 equal to, so we can put like W1 is equal to 88,290 Newton. Okay, and W2, we know the weight of the fuel is 15,450 Newton. Okay, so we know when an aircraft flies to a certain distance and a certain what to say time, for it flies for a certain time, its fuel will be consumed and automatically the weight will be reduced. So we can just put W2 equal to, you can write like W2 equal to 88,290 minus this 15,450. 15,450. Okay, so while solving we will be getting like 72840 Newton. Okay, 72840 Newton. Then what we need to find is we need to find the value of CL. Okay, But for finding the, what we need to find here is we need to find the range and endurance. Okay, just to see here, for the equation, sorry, the thing what we need to find is this engine propeller combination. So here, that is the equation is this one, and here we have CD by CL power 3 by 2. Okay, and now we can move for that range for engine propeller combination. There it is CD by CL. Okay, so first we need to remember, for finding the what to say, so like CD by CL means it will be at minimum power minimum drag condition, and for CD by CL power 3 by 2 means it will be at minimum power condition. So there are two conditions like this only you should remember. Okay, one is minimum drag condition, another one is minimum power condition. If in any problem there is a need of finding like CD by CL means, then we can consider it will be CD by CL will be minimum at minimum drag condition only. Okay, and minimum, for minimum power it will be CD by CL power 3 by 2. Okay, this will be if it is this condition is for CD by CL power 3 by 2. Okay, so first we need to do is we need to find the value for CL. So for finding the value for just we can go to that problem. So first we can find for CD by CL. Okay, that is CD by CL minimum. So here, for getting maximum rate, CD by CL should be minimum, or CL by CD should be maximum, or CD by CL by CD is maximum. CL by CD is max. Okay, when for this condition only we can get the maximum rates. Okay, so for that purpose, what I am doing is, here they have given the value for CD equal to CDO plus KCL square. Okay, so from that we can just find CLMD, that is for minimum drag. Okay, CLMD is equal to square root of CDO divided by K, square root of CDO divided by K. So here CDO is 0.022 plus for K is equal to 0.059. So by substituting we will be getting like square root of 0.022 divided by 0.059. So the answer is 0.6106. Okay, this is for CLMD. Then for finding CDMD is equal to 2 CDO, that is equal to 2 CDO. This is the formula. So for that we can put like CDO is equal to 0.022. So for 2 CDO 0.044. Okay, 0.044. Then next thing we can find for minimum power condition also. Okay, then we can substitute CL at minimum power condition is equal to CLMP equal to square root of 3 CDO divided by K, square root of 3 CDO divided by K. So for that square root of 3 into 0.022 divided by 0.059. Okay, that is equal to 1.058. Okay, so CLMD, CDMD and CLMP is found. Next is CDMP, that is CD for coefficient of drag for minimum power condition, that is equal to 4 CDO. 4 CDO equal to 0.088 8. Now we can substitute the value in CL by CD. Okay, straight away also we can find, or also we can straight away put that in our range equation and break out the equation. So I will find it directly here. First CD divided by CL, that is equal to, we will be getting the value like 0.0721, and here we need to find for CD by CL power M, that is CL power 3 by 2, CL power 3 divided by 2. So for that here we will be getting the value like 0.0808. Okay, so two things we have found. Next we can straight away put the formulas. So for finding this one is the formula. So in this we need to choose this formula only. So 8289.3 into eta p, they have given like 0.85 percentage, so we can put like a 0.85, and for W1 and W2 we found two values. CD by CL also we found, and we can I will substitute here the values. R is equal to 8289.3 8289.3 into 0.85 divided by BSFC they have given like 2.67. okay, 2.67 into 0.0721 ln or log to base 10. The total weight, that is 88,250 Newton, 88,250 Newton, and divided by 72,840, 72,840. Okay, so by calculating it, please calculate it. So the value is 3058 kilometer. Okay, 3058 kilometer. So next what we need to find is, we found the value for range. Okay, the next thing what we need to do is, we need to find the value for the endurance, maximum endurance. Okay, so for finding the value for maximum endurance, here we have for a propeller combination, the formula is E max equal to 1565.2 eta p divided by BSFC. So BSFC already we know, CD by CL power 3 by 2 is known, sigma into S divided by W1 into whole power 1 by 2, W1 by W or we can put like this: W2 whole power 1 by 2 minus W1 whole power 1 by 2. Okay, so here for finding this, we have they have given the value for eta v is given, bs of c is given, sigma s that also we know, and divided by w1 we found the value for w1, that is the initial thing, and for w2 also they have given like after find substituting the value of fuel, we found the value, some values like 72,840, so we can substitute here. So E equal to, I will substitute here itself. Okay, E equal to 1565.2 into eta v. For eta v, this is 0.85 divided by bs of c 2.67 into, for CD by CL power 3 by 2, we found the value like 0.0808. Okay, this is what we found. Then into at sea level condition, we know the value for sigma, that is 1 into the surface area they have given like 45 divided by the w1 is the initial weight, that is 88,250, sorry 290 whole power 1 by 2 into, for w2 72840 whole power 1 by 2 minus 88290 whole power 1 by 2. Okay, whole power 1 by 2. So after the calculations, you will be getting like 14.06 hours. So we can find the value in seconds also, or we can find the value in hours also. Okay, here we are finding it in hours. So generally thing is, we need to easy only, you can use whatever formula, whether you can write this formula also, just note this formula, or else you can use your Anderson book formula also, both are same only. But only thing is, here I have substituted all the values for that BSFC and the BHP and all, and then only I got this like this. Okay, and the remaining things also I substituted it and find the value, and the exact value only, this is the formula. The formula becomes like this. Okay, or else you can use the same thing here also. There it will be CT. CT is the specific fuel consumptions. Okay, here it is somewhat different. This is only, this is how we need to solve the range and endurance formula also. So next class we will see the coordinator turns and the remaining things also. Okay, so thank you so much.